Yeah, very close. Someone who is in the rolling. Schedule. Date. So day 1 will be Start streaming.
Somebody's voice. So you log in from the
Santosh, please pick up the phone.
Sir, what is the code, sir?
Where is the option, sir?
Sir, Google Meet, what is the code, sir?
XCO.
Capital, sir.
Not small. XCO.
X.
CO.
C.
O.
E.
Hyphen. EBQB.
ABQB, sir.
EBQB.
EBQB.
Hyphen HBG.
HB.
BG.
No, sir. Right, sir.
XCO. EBQB.
X.
CO.
CO.
Hyphen.
Hyphen.
EB.
EB.
EB. B.
EB.
Q.
E for elephant.
E for elephant. B for Bombay. Q.
Q.
V.
B.
B.
Ball.
B. B. B.
B, sir.
V8. Then H. B. Bombay. G. Goa.
No, sir, it is not working.
Not find the meeting. Meeting and other
I will send to you
message is
sir, where that was meet, sir? Settings, sir?
Google Meet is setting.
Google Meet settings, sir? Here, sir. Arun, sir. The Google Meet setting, where?
me, sir.
Yes, sir.
Google Meet.
Already allowed, sir? Not allowed.
No, sir. You can, sir.
Not can.
So once again, I'll give the request.
How many are there?
This meeting is full. Morning, Norway can't join. Norway can't come here.
Not allowed, sir. Yes. What is your email, sir?
So B. Santosh Kumar.
Option option.
The meeting is full, sir.
Yes, Santosh.
Sir, you remove 1 or 2 members, sir.
Again asked to join the
Hmm? Removed, sir. Removed. Send that request.
There are hundreds of algorithms, learning algorithms, but each algorithm is good for a particular set of applications, and each algorithm is good for a particular level of number of layers in the hidden layer actually. So once you do this function is there, right? So for example, what is the ReLU function? You find out the maximum between 0 and x. So that means whatever value you get x here, if it is negative, then you make it 0. If it is positive, you make it x. So that is what is a simple formula. Now similarly, so what is ANN? ANN means if you write ReLU function, then ReLU function is max of 0, and then this W1, X1, W2, X2, W3, X4, W4, X4, like this one, right? So you get A1. Similarly, you get A2, you get A3, you get A4, and then move to the next level. You get F3, you get Y1. Now what happens here? So how many neurons are here? Sorry, how many weights are here? Suppose you want to train it. How many number of parameters here? There are parameters. Here are the weights actually. So these weights. So how many are there? If you look at this, X1 is connected to 4, right? So X2 is also connected to 4. So this is 4 into 4, 16. Then these are 4. So 4, 16 plus 4, 20. And there is 1 here, 21. So this is total is 21. How many parameters are here? How many parameters need to be trained? 21 parameters to be trained. If there are 4 input variables, X1, X2, X3, X4, 1 output variable Y, and there is only 1 hidden layer that is called A1, A2, A3, A4. 4 neurons are there. So this is 21. Now look at the problem. The problem is that you look at the scale of the problem. Now suppose there is an input image. What is an input image? There is an input image like this. the input image is, every image is so this 3 stands for RGB, red, green, blue. So every pixel consisting of 3 values. What is the red value? What is the green value? What is the blue value? So red can be 100, green can be 200, blue can be 50. So every value ranges between 0 to 255. So what is the intensity of red? Between 0 to 255. 255 means blood red, complete red. 0 means no red. Similarly for green, similarly for blue. So every pixel, a combination of red, green, blue will be there, and you find a color there. How many rows? Suppose I have 400 rows here, 400 columns here. It's a square. So 400 into 400 into 3. So that is the number of data. So that x1, x2, x3, x4, what you are saying, will be now x1, x2, x3, x4, x5, etc. up to x 400 into 400 into 3. So this is the size of the image. So if this is the size of the image, so input will be now x 4,80,000. So the input size is now 4,80,000. And you say it is not a huge thing. Every image will have these many input values. Now suppose I have same number of neurons in the hidden layer. So A1 to A 4,80,000, and there is one here. So look at this. How many parameters you are doing? 4,80,000 this side multiplied by 4,80,000. So this is this layer. Number of weights here is 4,80,000 into 4,80,000. This is again 4,80,000, and there is only 1 8 here. So that's okay. So approximately 230 billion weights are there. I repeat, 230 billion. 1 million equal to 10 lakhs. 1 billion equal to 100 million. So that means 10 crores. 2,300 crores of weights are there. Now these 2,300 crores of weights need to be trained, need to be adjusted, need to be fine-tuned so that you provide the images, the required output will come. That's a huge. Even if you take a high-speed computing system, etc., it will take years together to train it. So this is what is the problem. Now, so the next thing is that we cannot have as number of inputs are there, as number of hidden layers. That is also not desirable. So what do you do? Suppose out of 4,80,000, you make it only 1,000 neurons. 1, 2, 3, 4 up to 1,000. So what will happen? 4,80,000 inputs multiplied by 1,000. So this is the 1,000. So these many number of weights here in the first layer. Then these are thousands here, and then 1,000 plus 1. But that is also again 480 millions. 480 millions means for 1 million equal to 10 lakh. So you can multiply that, right? So once you multiply that, so you get 480 million weights. So that means you look at the complexity. 480 million parameters need to be adjusted such that you provide an input and the desired output will come. Now what happens? We'll talk about deep learning. So this is the basic learning paradigm, learning models in an artificial neural network. But deep learning is slightly different. But so what is the famous quote about deep learning? Deep learning doesn't do different things, but it does things differently, right? So we'll see how it does things differently. It also does the same image classification, voice synthesis, data classification, etc. But it does things slightly differently and in an efficient manner. Now see. What happens here? That was only, we just discussed about only one layer. Now there are multiple layers actually. 1, 2, 3, 4, 5, 6, 7, 8, 25. There are so many layers. Now if you imagine so many layers means what is the amount of complexity it requires? So what it does? What is that algorithm it does? So what you do is first, you don't train, that's what I'm saying. You don't train the entire network. You don't go through the entire from left to right until the output and then come back and train. What it says, first you train the first 2 layers, input layer and hidden layer 1. Then the hidden layer 1, once you train it, then these 2, the next 2 layers will be trained. Then next 2 layers, then next 2 layers, and finally this layer. So what happens here? We are not training the entire network at a time. We are training only 2 layers at a time in the deep neural network architecture. So in the deep neural network architecture, training of the network is not possible or not done for the entire network at a time, but they are done in a phased manner. That's the first thing. So what we do in each one of them, so that's what the code here actually, each one of them, basically it is forced to learn good parameters, features that describe what comes from the previous layer. So now what happens? So here, these are the inputs, right? This layer will extract, suppose here we have some 1,000 inputs, and then you make it some, let's say 100. So number of neurons are 100 here. So out of 1,000 input vectors, the 100 features will be extracted. So 100 features means that 1,000 will become 100. That means out of 1,000 input vectors, only 100 features you extract, and that is a feature. So I'm saying that this feature is automatic. This is not the human intervene feature extraction. So it will find out the feature here. Now out of 100, suppose here we have 50, right? So out of 100, in this layer you extract 50 features. So finally it boils down to one feature. So that's a good way of multilayer neural. So what you are doing, when this slide is not required. So the intermediate layers are each trained to be auto-encoders. Auto-encoder means there are 1000 here. This 1000 will be represented as 300. This 300 will be represented as 100. This 100 will be represented as, let's say, 50. This 50 will be represented as 20, and this 20 is represented as 1. So the coding automatically happens. That means the 1000 will be reduced to 100, 300, 300 will be reduced to 100, 100 will be reduced to 50, 50 will be reduced to 20, and 20 will be reduced to 1. Okay. Now, what happens in a normal, another difference is that in a normal way, if you look at the number of samples, number of data sample size, so people say that, okay, my database consisting of 1000 images, my database consisting of 2000 samples. So can I use deep learning technique or not? So the problem is that in case of if your number of data items increases in this X scale, you see that the traditional machine algorithm, it starts learning very fast, even if the number of data samples are little less, but then very soon it saturates actually. It gets into a plateau. Very soon it saturates, right? But in case of a deep learning network, if you have more data samples for training, then what happens, the performance accuracy actually keeps on increasing. And at some point of time, it actually bypasses the traditional machine learning algorithm and still continues to perform well. So deep learning algorithm has an ability to perform much better than traditional ML algorithm if you provide more data samples. So what is the trade-off here? If you have number of data samples less than this value, then it is better to go for traditional machine learning algorithm like SBM, like neural network, etc. But if you have more data samples, then the traditional machine learning algorithm accuracy will be, let's say, 75%. It cannot go beyond that actually. The performance will be 75%. It cannot go beyond that, because after that it gets a plateau. But if you have more data and you want more accuracy, keep using deep learning algorithm so that you can continue up to 99%, 97%, 98%, etc. So, okay. Now we look at this. What it does actually, that's what I said. If you go back to this particular thing, if you see, first what is in the first layer, let's say this is an image. In the first layer, it will extract the low-level features. From the 1000, it will go to 300 low-level features. Then it goes for mid-level features, then high-level features, then trainable classifiers, and then you get whether. So, for example, this image, if you want to say whether it's a outdoor image or an indoor image, so from this image you try to extract. There is a bed, there is a window, there is a ceiling, there is a fan, there is a TV, etc. And then slowly these features will be converted to another feature. And then once your last layer will be only containing few features, and then it decides whether it's outdoor environment or indoor environment. For example, if you look at this, at the low level you get an image like this. After that first layer, you get an image like this. In the second layer, you get slightly better. In the third layer, you get the textures. Then you get these type of, look at this. There is a fan here. There is a bed here. There is a window here. So these informations, these features, and I repeat, we have not extracted these features. These features are extracted at different layers automatically, and then finally you decide whether it is a output layer or not. So what happens in the input, you get pixel values. Then in the lower level features, you get the edges. You only get the edges of the picture. Then you get the texture. Then you get the motif, and then you get the different objects or parts there. And then finally you decide whether it's an object or not. For example, you take a face image, right? From the face image, you first find out the edges. So the edge, only the edge means line image actually. Now once you get the line image, then you get the texture, the various textures of the face. Then you get the motif, and then you find there is a nose, there are two eyes, there is a ear, there are hairs, there is a lips. So, and finally you say that, okay, it's a human face, or it's a whatever it is. So this is how we say that each module in deep learning transfers its input representation into a higher level one in a way similar to human cortex. So for example, if I look at the image, initially I see only pixel values, right? Red, blue, green, etc. Then finally I see that there is a window there. There is this is a white skinned fellow. He uses a spectacle. Then finally I get to know that okay, there is a nose. Then I find that okay, this is a long nose, this is a big eye, this is a fair complexion, and slowly I find out that who is that object. So that is how in fact the human cortex, people say that the human cortex also does like this. Now, as you said, I mean, this is what is the deep learning architecture is that. But how the deep learning convolution, how the learning actually happens. Now, so this is called convolutional neural network or CNN, and CNN is a very, very famous, most popular form of deep learning. There are many deep learning algorithms are there, architectures are there, but we will be discussing CNN here. So in the convolution layer, first thing that you should know what is convolution. Now let me see what is convolution, how convolution is calculated. Now let's say you take a matrix with A, B, C, D, E, F, G, H values. So this is a matrix, and how do I calculate the convolution? Now you take a filter. What is the filter? Some value, W1, W2, W3. Now I'll also tell you that how these filters are calculated, how the filters are found out. But imagine that we have another 4 numbers. So A, B, C, D, E, F, G, H are the numbers. W1, W3, W3, W3. So let's say W1, W2 is 1, minus 1, minus 1, 1. Right? Some number, some W1, W2, W3, W4. Now what happens here? If you look at this, now what is the convolutional image? How do I calculate it? How do I calculate it? This A, B, E, F, I take 2 by 2 because this is 2 by 2, I take 2 by 2. And then you multiply this with this. Now look at this. You multiply A with W1, B with W2, A W1, B W2, E W3, F W4, E with W3 and F with W4. Now once you multiply it, once this multiplication is over, you sum them up and then there is a function. The function can be a simple sum, the function can be anything. Once this function you do it, now this value is H1. This value is H1. So to find out this value, you have to do this calculation. Now what happens after you do this, H1 is calculated, right? Now next, move this. I go back, move this window. Now from A, B, E, F, now it becomes B, C, F, G. Now this B, C, F, G multiply with the same W1, W2, W3, W4, and then what you get? You get H2. So this is H2. Similarly, you calculate H3, H4, H4. So this is what the input image is converted to a convolved image. The convolved image, that this is a feature map. So that means what? From a 4 by 4, I have reduced it to a 3 by 3. Right? So 16 is reduced to now 9. Sorry. Now if I make it a 3 by 3 matrix, if I make it a 3 by 3 filter, right? Then what will happen? It will become 2 by 2. The convolved image becomes 2 by 2. So 4 by 4 becomes 2 by 2. If you take a 3 by 3 filter. Okay. So number of parameters for one feature map is 4 here. So if you look at this feature map, number of parameters is 4 here. Then you continue to do this. Now, so the number of parameters in 100 feature map is 4 into 100. So whatever number of features, so each one is 4. If there are 100, that will be 4 into 100. Now look at this, how the filter works actually. In this case, in one of the convolution layer, this is a standard filter. The filter is 0, 1, 0, 1 minus 4, 1, 0, 1, 0. Don't worry about it. How do I arrive at this? I will tell you how do you arrive at it little later. So let's say this is an image. Now this image, you take this image, whole image, and this is the small filter. The filter corresponds to 0, 1, 0, 1 minus 4, 1, 0, 1, 0. Now this filter, so first you try to apply the filter here, then so it keeps on moving, right? And then slowly it will move like this, like this, like this. Now look at this. This keeps on, the filter keeps on moving. And after you apply this filter, look at the image. So if you apply this filter and then print the image now looks like this. So the original image is this, the filtered image is this, or the convolved image is this. How this image I got it because I've used this filter. So now there are hundreds of standard filters are there. It's already reported in the literature. People have done experiments and people have done reported that if you want a kind of an edge of a picture and you don't want any color, etc., please use this filter so that the image can be converted to a simple, small, and only the lines, nothing more than that. So the input image, if you use the convolutional neural network, will become like this. Okay. So this actually, how do I do? And in fact, there is a paper by Wissel in 1962. He published a paper that how the human neurophysical system works. He conducted the experiment and how it works. And based on that 1962 paper, people now using CNN or using deep neural algorithm develop this. Now, what is this actually? That's what I'm saying, right? W1, W2, you keep on changing actually, right? So this multiplied by W1, W2, W3, W4 becomes this. Then in the next layer, you have W5, W6, W7, W8. So this is layer 1, this is layer 2, this is layer 3. So that's very simple. Now you apply filters in each layer. So the filters will extract some features. So in the first layer, from first layer to second layer, apply a filter, you get some features. So this is layer 1 feature map. Then apply another filter, you get layer 2 feature map, and so on and so forth. Okay. Now, once you get a convolutional feature maps or convolved feature images, then what you do? There is a concept called pooling. Now, what is pooling? Pooling means there are two types of pooling, and there are other pooling also, but mostly there are two types of pooling people are using. Max pooling, that means reports the maximum output within a rectangular neighborhood. Now I go back, or okay, let me see. Okay, this image is there, and there is an average pooling. Now suppose you get a convolved image like this, right? If you get a convolved image like this, 1, 3, 4, 2, 5, 3, 1. Now what you do? You take a 2 by 2 window. So 2 by 2 means this is 2 by 2, this is 2 by 2, this is 2 by 2, this is 2 by 2. What is max pooling? Max pooling means within this 2 by 2 matrix, what is the maximum value? So the maximum value here is 4. The maximum value here is 5. The maximum value here is 3. The maximum value in this one is 4. Right? Now see. So the max pool is a 2 by 2 filter with stride of 2. Now look at this, look at this 4, 4, 5, 3, 4. That's what we did, 4, 5, 3, 4. So 4, 5, 3, 4, 4, 5, 3, 4. So this is what is the max pooling. What is the average pooling? Average pooling means you take the 2 by 2, all the numbers, find out the average and do it. So this 4 by 4 matrix, convolved matrix, now can be converted to a 2 by 2 because you have taken a 2 by 2 filter, and this 2 by 2 filter using the max pooling or average pooling you can convert to a 2 by 2. So that is what I am trying to do is that, or what the deep neural architecture says that, see, the number of layers, the number of neurons in each layer has to be reduced because you cannot be fine tuning or cannot be training billions of values actually. So that's what they do. So this is, so the convolutional neural network, what happens now if you look at this, right? So this is how it works. So the multiple layers are there in each layer. So this is the filter. So the filter is 8 cross 8. So 64 filter you have used. So this image you have taken, 8 cross 8 filter is used, and then another filter is used. This red says for you go for a max pooling. So this is how a complete architecture is there. Now after that you get whether it's a living room, whether it's a bedroom, whether it's a kitchen, whether it is a bathroom, whether it's an outdoor. So all these things you get by looking at the image itself. Now, this is very, very important actually. This slide is very important. So still now what we discussed is that what is the convolution, what is the deep learning framework. Then we discuss what is the deep neural architecture, that means multiple layers. Then we discuss how learning happens in multiple layers using a convolutional neural network framework. And after that, we see that how do I do it actually. Now, if you today, tomorrow or day after tomorrow you want to use deep learning network, the basic problem is that look, there are millions of weights are there actually. Now how do you know? First thing that let me go in this way. How do I know? First question comes, there are so many things here, right? First question comes that how do I decide a filter? What is the size of the filter? Then what will be the value of those filters? Once you know the filters, then next is that there are every layer you have a filter. So suppose there are 30 layers, then in each layer you have to find out what filter works good. In each layer you have to find out what max pooling or average pooling works well. Where you use pooling, where you use filter, what size of filters, and how many neurons. So there are so many. The architecture, building the architecture is so difficult, so complex that you cannot just do it today or tomorrow, because there is a lot of issues there. There are a lot of training required, lot of experience required for that. So people who are not from deep learning or deep neural network research domain. So deep neural network research domain people are doing this actually. Which polling algorithm they should use, or which filter they should use, what are the values of those filter, how many layers they should use, etc. That is the core deep learning people are doing that actually. Now what happens here in this case, okay. So in this case, imagine how many, okay. Any questions? Okay. Let me continue. So what is
not visible?
Slide not visible?
The PPT not visible.
Now?
Sir, it is visible, sir. Visible, sir. Yes.
Okay.
It's visible, sir.
Okay. So maybe Dr. Kantat, you can try again.
Okay.
So what is that transfer learning does? You know what is transfer learning? Transfer learning means you learn something in one environment and use that learning experience in some other environment. The best example I think you might be knowing, Mahendra Singh Dhoni was not a cricketer earlier actually. Mahendra Singh Dhoni was actually, so in this architecture, what is he doing? He actually was playing football. He was a goalkeeper in football actually. So one day the coach in the cricket in the Ranchi, his wicket keeper didn't come. So the coach there asked Dhoni that you come and do the wicket keeping. Now he did the wicket keeping in that match, and after that, the rest is history. Now how he could do the wicket keeping immediately? Because he has that learning in the football, goalkeeper football, and he used that learning in the cricket also to learn it quickly, right? So in this case also what happens is, suppose I do a deep neural network architecture, the various layers, etc., and learned it using for image processing. Now can I use the same learning algorithm in voice synthesis? Can I use the same thing in the sensor network algorithm? So people say that this transfer learning means instead of starting from the scratch, you can start from a particular point and then start learning. So that is called the transfer learning. So one learning in one environment or in one application or in one problem should be transferred to some other learning. So that is what is called transfer learning. So that's what I said. Deep neural architecture determination is difficult. You cannot determine how many layers should be there, which filter should be using, which polling should be used, where you should be used, what is the filter values, etc. It involves millions and sometimes even billions of parameters to be tuned. So it's not easy. What the researchers have done in the deep neural network, and they have made our job a little easier, and that is why it has become very popular. For example, the researchers have worked on different architectures and suggested some already trained deep neural architecture. I repeat here, suggested a few already trained deep neural architecture. That means what? They have already decided that how many layers should be there, which filter should be there, where should be the max pooling should be done, what should be done. And one architecture they have done, they have adjusted the weights, etc. So they might have worked for 1 year. So they have adjusted the etc. And now they say that, okay, AlexNet is an architecture of deep learning in which there are 25, I'm not very sure, but I'm just giving an example. AlexNet is a type of deep neural network where there are 25 hidden layers. They have used a particular filter, they have used different type of max pooling, and it is already trained. So if I want to use for my application, what I do, so AlexNet code, AlexNet architecture is available in Python, it's available in MATLAB. So what I do, I take that AlexNet, use my data, and it is already trained, and using that AlexNet trained architecture, I train my data. So you see, there is already trained deep neural network, number of layers, etc. Everything is fixed. Filter is fixed. Everything is fixed. You just give your data, get your output. Now, if you are not satisfied with the output, then from that learning, there is an incremental learning. It will only learn another 100 iterations or so, and then it is perfect. Similarly, we have VGG19, 2019, people have suggested this, ResNet 50, MobileNet V2, Inception V3, and so many. So in your application, suppose somebody is doing mechanical engineering, robotics, self-driving car, etc. In your application, for your data set, what do? You go to Python or you go to MATLAB, etc. Use your data set with AlexNet, with VGG19, with ResNet 50, etc. and find out which works better for you. So if that is the case, then it becomes very, you learn quickly. So the transfer learning in that case, somebody else's learning, I take it out, transfer it to my application and start learning. So that is what I'm saying. You can use that learning experience and use it in another application. And this is very important to start quickly. Now, if you're not very happy with any of these networks, then you can think of your own network, your own filter values, etc. And that can come from your experience. Nobody can suggest it actually. Now, let me go for a small application which is known as deep learning framework. So in short, what I have discussed is that I have discussed what is deep learning, what is deep neural architecture, what is max pooling, what is filter, what is convolutional neural architecture, and all these things we have discussed. And then we'll discuss a small application which we have developed on our own in our lab. We have done many things, but I will try to see at least a couple of them in there. So deep learning framework for gesture recognition. What is a gesture? So for example, input to the system, I mean, particularly in the corona time, etc., we don't want to touch. So gesture is that key. There are many ways that we communicate with the other fellows, right? Fellow human beings. Sometimes we just move our hand like this, go. And I don't say anything, I'll just gesture out. For example, while I'm presenting this framework, one of my colleagues entered into my room. I just gestured him that I'm in a meeting and please, we'll meet some other time. So that kind of a gesture. So gesture means non-verbal communication, non-touch communication, non-contact communication is a gesture. So we will try to see that how do I determine the gestures by using deep learning framework. So this is the problem statement, building a deep learning model for IoT framework for gesture recognition using non-invasive body-mounted sensors. So what I do, I'll show, there is a video also here. So you have a device, the device is on your hand, and when you move your hand, etc., the device should be able to find out what is that you are going to say, what is that command you are giving, and based on that command, it will take out something. So our main goal is to develop a IoT framework for gesture recognition using, there is a sensor, MPU 6050 mechanical IMU sensor. What is this actually? This sensor actually find out the accelerometer. That means your change in the XYZ direction. It also finds your angular movement. Angular movement means your change in angle. Suppose I move my hand like this, right? So the angle will change. If I move my hand horizontally, there is a change in the XYZ direction. So to find out the angular movement, it will also find out the linear movement. And we have used the convolutional neural network, what we have discussed so far, to classify the dynamic hand gestures. So, I mean, you know this, the motivation is that interacting with computers using only a pen or a keyboard or a mouse is not sufficient. We need more flexible and natural way of interacting with computers, which makes the interaction more easier. Gestures are not only used to interact among ourselves, it can also be used to interact with the machines. Now, can you use these gestures? So now the another thing is that you can have a camera. That kind of work is already there. If there is a camera, in the camera you try to gesture it, and based on the camera, but that requires a different type of setup actually, right? But suppose I have an Apple Watch or a Fitbit, can I use a small gesture recognition sensor and then try to recognize what I'm trying to say without any camera, without anything? So the contactless entry control of home appliances. For example, I want to switch on the fan, I want to go to the lift, go up, go down. So I will just and touch the keyboard, etc. Right? So without doing anything, I should be able to, in a contactless manner, I should be able to do what I want to do it. There are some existing work. I don't want to talk about these things. Basically, I'm trying to say that various machine learning models have already been used. K-nearest neighbor, support vector machine, random forest algorithm, hidden Markov model has already been used. But we have used a deep learning based models actually. So what are the sensors? People have used gyroscope, accelerometer, magnetometer, EMG sensors, and so many things. And gesture based interactions are already there in computer games and all that. But we'll see what we have done. I'll just tell you that we have used some hardware actually. It's not very thing. We have used ESP8266 controller. People who are not from this background may try to ignore it. It's a controller, name is ESP8266, and you have a sensor suite called MPU6050. If you look at this, so this is my MPU6050. It has 3 accelerometer and 3 axis. 3 axis accelerometer means XYZ direction, and 3 axis angular movement. So it can measure the angular movement. It also can measure the linear movement. And then it also says that so there are other things. How do I connect and all these things, right? So if you look at this is a 8266 ESP8266 controller. So there is a processor. There is everything there. Now, what is that actually? If you go to this, so this is actually, if you're not very interested, you can ignore it. But this is actually what you've done. We have done with ESP8266 controller and MPU6050 sensor suite. Now this is how the connections are done. So this is my MPU60 thing, and this is my node MCU, that is ESP8266. These are the pins, you just connect them. So that means what? From the data from here will come to this controller. Then I write my code here, deep learning code here, and dump it here so that it recognizes the gestures actually. Now what you have done, so what you do, you read the IMU sensor part, look at the flowchart here, read the IMU sensor part here, so you get the X, Y direction. Then you find out, because you have to find out that, okay, the hand is now moving, so the threshold is triggered, right? And then you record the data and segment gestures. Then you try to segment that, what is that he is trying to see. Then you try to find out the classification, what type of gesture it is. We have used Arduino, this IDE. Arduino IDE means Interactive Development Environment, using the program ESP to program the ESP controller. ESP tool is a software by which we can put the data into the ESP8266. So it can flash, you can put the data. UPy loader also, you can transfer the files. Anaconda is a programming environment for CNN implementation. So if you want to use CNN implementation, there is a Keras library in Python. So Keras library in Python under Anaconda environment. I think people who are using Python should be knowing it. If you have not used Python or not used Anaconda, don't worry. Just install Python, you know what is Keras, what is Anaconda, etc. So under Anaconda, the CNN implementation modules are there actually. That's what I'm trying to say. So we borrowed modules from there, used it in our program, embedded into our ESP8266 controller using UPy loader. And then first we use the environment to code it, and then you flash it, format the ESP8266. Then using UPy loader, I dump that code, and to develop the code, I have used Anaconda environment. Now, what is that we have done? We are using total of 6 actually not features, actually 6 data. So what are the data? X-axis, Y-axis, Z-axis, linear movement, angular movement, theta x, theta y, theta z. So, and then what you are doing, you are collecting frames actually. Frames means when you move your hand and other things, the values will continuously change, right? So this movement, we are taking 54. In fact, we did a lot of experiments and you find that 54 records. So for example, what is this 6? So the total dimension is, what is this 6? 6 is accelerometer x, accelerometer y, accelerometer z. That means linear movement. Theta x, theta y, theta z. That means angular movement. So this is in one frame. So we take 54 such consecutive frames. So total dimension is 54. So 54 into 6, we take it and then try to classify what type of event it is, right? So okay. Now what you do? How do I create the data set? So data set is collected using these two. This is the controller, this is the thing. I've asked, 10 of my students, 10 individuals, all are male students actually, between 21 to 30 years of group. So they use this device to do the gestures. And the gestures are done using only right hand. We have not considered yet left hand. The number of samples collected for each individuals are not same. So somebody did it for 10, somebody did it for 20, somebody did it for 30. So we have not done that. Data set is collected with a window size of 54. Delay of 1 millisecond is used between each frame. So we collected millisecond wise data. So what is the scale factor? You don't worry about it. Now, what is that we are trying to do actually? We are trying to classify 26 alphabets and 10 digits. So total 36 classes. That means what? In my hand, I will move my hand like 0. If I write 0 in my hand in air only, then it should recognize it as 0. 1, 2, 3. Similarly, A, B, C, D. So 26 alphabets, 10 digits. Then for each alphabet, as I said, for example, A. So A means there are 10 individuals, they write A some 30 times. So there are 300 samples of each class. So total, what is the data set? 10,800 data sets we have. 26 alphabets, 10 digits, 36 classes. For each alphabet and each digit, you have 300 samples. 300 samples are collected from 10 different individuals using right hand gestures only. Now, I think if I go to this particular thing, this is what I have already said, right? So what I have done, then once you collect the data, we have used the filters, we have used the max pooling, you have used padding. Why you have used padding? Because there are some alphabets, some digits where the data is not there in every frame actually, but you have to make it uniform, right? Because say for example, 1, I write it very fast, but if you want to write 8, I have to write 8 like this. So 8 takes little more time, so the data is more. 1, the data is less. So where the data is less, I put number of zeros in the rows and columns so that the matrix size becomes same. Now, once you do this, I think, let me see, just see the video and then we'll discuss. So the student actually worked during the lockdown actually at his home. Now see, 3. He gestured 3 and the system recognized 3. In fact, the system is recognized 3 in the laptop, but I am putting it here. Now there is a wrong thing here. Just a minute. 3 is correctly recognized, but for once, this H actually classified as a 4. So this is the wrong thing, but now look at this H. Again it is H, this is also H. This is Y, but actually it recognizes the X. Now Y, Y. Z, Z. X, X. So what is this actually? This device will be tied to your hand, and in your hand you write X, you write N, you do these things, and then in the laptop it is showing that the data is going to the laptop. So I'm interacting with the laptop and telling that look, I'm saying you yes. So a command, suppose I want to command dir, right? So I can type D, I can gesture D, I can gesture I can gesture R, and the laptop will read it as a dir, like that is the directory command, and display the directory of the drive. So this is how we interact with the system using gestures actually. Now the gestures are not, it's not easy. So what we did, so this is how, and that's what I said. I use max pooling, I have used convolution, I have used max pooling. So these are the 7 layers we have used, and in each layer, how many filters? 32 filters you have used, 3x3 kernel you have used. So all these things we have borrowed from a Anaconda configuration, and then we tried it. So this demonstration video you have just seen. Now what is that results we are getting? The results what we are getting is basically first we try to see that, as I told you at the beginning, that with less data, are you able to get good accuracy or not? So what you do is, instead of taking 300 samples, because we thought 300 samples, 36 alphabets, 10,800 is too big to train. So first we took, okay, let us take only 10 samples. Then we took 100 samples. Then we took 300 samples. What do we use? We have used 80% data for training, 20% data for testing. So out of this 10,800, I divided it into 80% for training, 20% for the testing, right? So what do? If you take 100 data set consisting of only 100 samples, the accuracy is only 52%. But if you make 1,000, how do you make 1,000? That means 1,000 data, instead of creating 10 samples, we created 1,000 samples actually. So for digits, how many digits are there? 10 digits are there. If you take each digit 10 times, that means each digit for 10 samples, then it is 100. Each digit 100 samples, then it is 1,000. The accuracy becomes 96.6%. I still make 3,000. 3,000 means what? 10 digits and 300 samples. 300 samples, how do I collect? 10 individuals, and each individual did it for 30 times. So they do it 30 times. 3 they write 30 times, 4 they write 30 times, 5 they write 30 times, 8 they write 30 times, etc. So if I take 3,000 samples for classifying digits using deep learning network, I got 98.67%. If you do the same thing with only 1,000 samples, then you get 96.6%. If you use only 100 samples, then you get 52%. So that's what in one of the slides I said that if more data is available, your accuracy increases compared to the other thing, right? Now, what do you do in case of alphabets? There are 26 alphabets, each alphabet 10 samples, so 260. But you look at this, the accuracy is only 64%. If I make 26 alphabets, each alphabet 100 samples, the accuracy is 98.42%. 7,800, 26 alphabets, 300. So 7,800, if I take, the accuracy is 99.29%. That means 99.29%, you are trying to accurately predict what is the gesture, what is the alphabet when you write it in the thing. Now, why the alphabets are giving a slightly better result compared to the digits? Because there are some overlapping digits, right? For example, 3 and 8 is difficult. So sometimes for some people 3 and 8 is confusing. So these confusions make the accuracy a little less. 6 and 9 there is a confusion. So, but in case of alphabets, they are actually slightly separate. Now there is another problem actually. How do you distinguish between 0 and O? So 0 and O we could not distinguish because alphabet and digit 0 and alphabet 0, as far as gesture is concerned, is same. What we did in this case is that 0 we are writing clockwise and O we are writing anti-clockwise. So that's how we distinguish actually. So similarly, if you take both result and digits together, I repeat, both results and digits together, then it becomes 36 classes. Each digit and alphabet, if you have 10 samples, then 360, accuracy is only 59%. 3,600, accuracy is 97.8%. 10,800, accuracy is 98.52%. So look at this, the more the samples using deep learning network, your accuracy can increase. But what happens is that, so finally when we want to test the system, so this is what is everything done. Now I call a student and I said that, look, you do a gesture. Take this device and do a gesture. So we collected real-time data stream of 80 gestures. Out of 80 gestures actually, so first thing is that you have to collect that 54 segments, right? So I'm not able to collect the 54 segments because of some problem. He did it like this, etc. So 5 gestures we could not recognize that this is a gesture itself. So we could not do that. But only 75 gestures we could correctly say that, okay, it's a gesture. Once you know that it's a gesture, out of 75 gestures, 74 gestures are correctly classified. So what happens actually, if you put it together, that means out of 80, you could only classify 74 gestures correctly, because 5 we could not even recognize it as a gestures, because those are different students actually, not the students with whom I have taken the reading for the training. So the gesture segment is 93.75% accuracy, because out of 80, 75 gestures could be correctly think, 93.75 accuracy. Out of 93.75 accuracy, only one could not be classified properly, 75 to 74. So the gesture classification accuracy is 98.67%. But if you put it together, that means out of 80, I could classify properly 74 gestures. So if you, out of 80, 74 gestures are properly classified. So total overall system accuracy is 92.5%. There is a system which is already working in the literature called Gesture Keeper. So we compared that Gesture Keeper, which is already IEEE transaction paper actually. We collected that, and they are using hidden Markov model, right? And I am using deep neural network architecture. So that's the difference. So they have used only for 12 classes. They have used for 6 digits and 6 alphabets. We have used for all digits and all alphabets, that is 36. Their window size is 125. They have taken a larger window size, so it takes a lot of time there. We have used only 54. Their accuracy, gesture accuracy segmentation is 87%, ours is 93.75%. And then the overall accuracy in our case is 98.67%, in there it's 97.89%. So that I want to say that the DNN or the convolutional neural network using deep neural network architecture works much better in case of this. So this is the confusion matrix. Actually, if you look at this, it's almost 100. It's only in some cases, in 1 or 2 cases only. So this is ABCD 0, 1, 2, 3, 4, etc. And this side also 0, 1, 2, 3, 4, etc. So 0 is always recognized as 0. That's 1. 1 is recognized 97% of the time. 1 is recognized as 1. In 3 cases, for example, 1 is recognized as 7. If you look at this, 1 row and 7 column. You see, there is one case where 1 is recognized as 7, and you can imagine 1 and 7, they are almost same. So one student, when he wrote 7, it is recognized as 1. So this shows that this confusion matrix shows that okay, oh my God. This confusion matrix shows that you are in the right track and the system is working pretty well. So the conclusion here is that the CNN works much better for classification of dataset as if the dataset is big enough. Dynamic gestures to represent digit 0, alphabet O, that's what I said, we do it in a different way, in the opposite direction. O is taken as clockwise, 0 is taken as anti-clockwise. Now, we have proposed an adaptive threshold setting algorithm that I didn't discuss it in detail here. So the final accuracy system is 92.5% system, right? Okay, I think I'm running out of time. I could have discussed. So we have also done some work on sensing without sensors. For example, using the same device, how can I detect the human activities, whether he is falling down, whether he is standing up, whether he is running, whether he is sitting. That also we have decided something, but right now will not. I think I will not be able to discuss. So thank you very much, Dr. Gantayat. I should stop here. Hello.
Sir, good morning, sir.
Very good morning.
I have some few questions about this topic, sir.
Yeah, please.
So can this CNN model is work for text data also?
Yeah, it will work for every data. It will also work for text data. It will work for everything. You know, it works for signals. It works for text. It works for images. So, for example, in NLP, if you just type in Google, in natural language processing, people have used deep learning network extensively now. Extensively. So it works for text data also.
Thank you, sir. So how can we know that which weights are going to be being which features are going to be having more weights, and how can we identify those features? That
is the beauty of this algorithm, that you don't have to worry about anything, right? What you have to do is that you only give the data and you use any VGG19 or mobile insertion net or something, some already trained network, and you see that the output are coming. So the good thing about it is that I don't have to worry about which feature I will use, which filter I will use, which things I will use. I will not worry about this. I will only give the data. I will use a particular deep neural network architecture which suits me, depending upon the. If you go through the paper, in the paper you will see that they have explained an application, and that application for this network is working good. If that is suitable for your application, you use that network actually. So I'm not worried about which feature, which weight, etc. Everything is doing that. And training is doing this combination actually.
Okay, sir. The hardware configuration is going to show any difference in terms of accuracy?
No. It only difference in terms of time.
Okay. But we will get the same accuracy value.
You will get the same accuracy. You will get the same accuracy.
Okay. But we will find some difference in execution time only.
Yes, you will find a large difference in execution time.
Okay, sir. Thank you, sir. So these are my few questions from my side.
Thank you, Malika.
Very good morning, sir.
Very good morning.
This is Dr. Aditya Kumar Sahu, sir, from Gmrit.
Tell me, sir.
Sir, actually, I have one doubt, sir. We are doing this, we are identifying the edges from the image, na, sir.
Okay,
using many kind of filters.
Yes.
So that's finding the edges impact on the accuracy or any kind of output. like many edge detection techniques are there. They find more edges from the image compared to
Yes.
some other edge detection techniques.
Yes. Yes.
So the choice of edge detection techniques, I mean, does gives any kind of input.
Okay. So that's what I started at the beginning. We are not worried now about which algorithm we'll use for edge detection, which algorithm I will use, whether this is good or that is better or something. I am saying that I'm giving multiple layers. In one layer, you will find out some thick edges. In another layer, it will find out some thin edges. So you are not saying that you find this edge or not find this edge. Our ultimate objective is that to increase the accuracy. So the deep network architecture automatically tunes itself to find out all the things that are required for increasing the performance. So now which edge detection algorithm I will use, I'm not worried about that. I'm not using any edge detection algorithm now. What I'm doing is that I'm only giving my image, different layers, find out different edges, different textures, and then finally they learn naturally. Right? So you are not worried about which edge detection algorithm I will use. I'm not using an edge detection algorithm.
Oh, thank you, sir. Thank you very much, sir.
Thank you. Okay. So in fact, if you have any questions and all that, you can always mail me or write a mail or send me on WhatsApp. I should be able to immediately explain. So what I want is that you try to look at Python or MATLAB immediately and look at VGG19, look at MobileNet, look at AlexNet. That's very popular. Look at AlexNet, etc. And see that if you have some data, quickly train it and you get a feel of that actually. So if there are no more questions, Dr. Gantaj, I would like to take
Okay, sir. Okay, sir. Anyone have any questions? Please. Okay. There are no questions, I think. Thank you, sir, for this valuable information and how to implement algorithms in deep learning or deep neural network. So there are so many algorithms available, and many are also working on different aspects.
Yes.
Again, there are also so many new models also coming every time. So thank you, sir, for your coming to the FDP. Okay, thank you, sir.
Sir Siba sir, thank you very much for giving nice presentation over deep neural
Thank you very
network.
much. Thank you very much. Namaste and have a good time. Thank you, Gantaj. It's good to see you after a long time.
Okay. Okay, sir. Namaskar, sir. Okay. So all the participants, the already mail message sent in WhatsApp group. The feedback link is available in the YouTube, and link also given. So you have to fill your feedback from the YouTube only. Any questions?
Sir, sir, we are attending from Google Meet. Then how we give the feedback, sir?
No, already given the. Okay.
We are attending through Google Meet. We should
Okay.
switch our. Please post it here also, sir.
Okay. Right.
Sir? Prasanga, sir? Sir, sir, it's available, sir, but I didn't get ID, sir. FD ID. Where should I get, sir?
What is your madam?
Name?
What is your
Yes, Manjula.
name? Yesterday I sent the mail to everyone.
Mail.
Yesterday I sent.
Yeah. Okay, sir. Okay, sir. I'll check it, sir. I'll check it.
Okay.